Hey guys, welcome back to my YouTube channel. My name is Bhanu Chandra and I'm studying in Sri Venkateswara College of Engineering. I'm a first year student into engineering and I'm currently in the second semester. So my USN is 1VE23CD007 and today we'll talk about the subject Introduction to Mechanical Engineering, and the subject code of this is BESCK 204D. So today's topic will be working of 4-stroke petrol engine and 4-stroke diesel engine. So today's session will be divided into four parts. So first we'll learn about four-stroke petrol engine. Then we'll learn about the PV graph for petrol engine. Then continuing with four-stroke diesel engine and PV graph for the four-stroke diesel engine. So coming first, four-stroke petrol engine. The four-stroke petrol engine is the working principle of four-stroke petrol engine is Otto cycle, and the four strokes in a petrol engine are suction stroke, compression stroke, power stroke or expansion or working stroke, and finally exhaust stroke. So coming first, suction stroke. This stroke starts when the piston is at the top dead center and about to move downwards. And during this cycle, the inlet valve is open and exhaust valve is closed. And due to the low pressure created by the downward movement of piston, the charges, which are the mixture of air and fuel, is drawn into the cylinder. So the work is going to be done on this mixture of air and fuel. At the end of the stroke, the inlet valve is closed. So coming next, the compression stroke. During this stroke, the fresh charges are compressed due to the movement of piston from bottom dead center to top dead center. So which is this piston will move from bottom dead center to top dead center so that the charges present between the cylinder walls and the piston will be compressed. And during this stroke, this inlet valve and exhaust valve will be closed. As the piston move upwards, the air and petrol mixture in the cylinder is compressed adiabatically. The pressure and temperature of the charges increases. Uh, when the piston reaches the top dead center or just before the completion of the compression stroke, the spark plug which is inserted in the cylinder head ignites the charges. So the next one is power stroke. At the beginning of the stroke, the piston is at the top dead center, and during the stroke, the piston moves from the top dead center to the bottom dead center, which is from top, it is dragged downwards. And during this stroke, both the inlet and outlet exhaust valves remain closed, and the combustion of fuel liberates gases, and these gases starts expanding. Due to the expansion, the hot gases exert a lot of force on the piston, and as a result, the piston is pushed down from top dead center to the bottom dead center. So the power impulses is transmitted down through the piston to the crankshaft and through the crankshaft and the connecting rods. This causes crankshaft to rotate at high speed. Thus, the work is obtained in the stroke. Hence, the stroke is also called as the working stroke. So the last one is exhaust stroke. At the beginning of the stroke, the piston is at the bottom dead center, and during the stroke, the piston will move from the bottom dead center to the top dead center. And during this stroke, the inlet valve is closed and the exhaust valve is open. As the piston moves upwards, it forces the remaining burnt gases out of the cylinder to the atmosphere through the exhaust valves. When the piston reaches the top dead center, the exhaust valve closes and the cycle is completed. So in the next cycle, the piston, which is at top dead center, moves to the bottom dead center, thereby allowing fresh charges to enter the cylinder, and the process of the whole cycle will continue. So the PV graph for petrol engine. So we can see this is the PV graph for the petrol engine. The suction stroke is represented by the line AB in the PV graph, this line. The combustion of fuel takes place at the at constant volume as shown by the line CD on the PV graph, this line. And in the power stroke, the expansion of gases is adiabatic in nature and it is shown by the DE curve in the PV graph. So this curve. The exhaust stroke is shown by the line EB and BA on the PV graph. EB and BA. So now the four-stroke diesel engine. The working principle of four-stroke diesel engine is based on theoretical diesel cycle. Hence it is called diesel cycle engine. So the four strokes of the four-stroke diesel engine are suction stroke, compression stroke, power stroke or expansion stroke or working stroke, and finally exhaust stroke. So the first one is suction stroke. So at the beginning of the stroke, the piston is at top dead center, and during the stroke, the piston is drawn back or it is moved from top dead center to the bottom dead center. And during this cycle, the inlet valve is open and exhaust valve is closed. So the downward movement of the piston creates suction in the cylinder, and as a result, fresh air is drawn into the cylinder through the inlet valve. So the second one is compression stroke. At the beginning of the stroke, the piston is at bottom dead center, and during the stroke, the piston will move towards the top dead center. That is, the cylinder is filled with fresh air, and the piston will move from bottom dead center to the top dead center. And during this stroke, both the inlet and exhaust valves are closed. As the piston move upward, the air in the cylinder is compressed at high pressure and temperature. So at the end of the stroke, the fuel, which is the diesel, is sprayed into the cylinder by fuel ejector. So this is the fuel ejector, and the fuel comes in contact with the hot and compressed air. It gets ignited and undergoes combustion at constant pressure. So the power stroke. At the beginning of the stroke, the piston is at the top dead center, and during the stroke, the piston is moved from top dead center to bottom dead center. During the stroke, both the inlet and outlet valves are closed. So at the combustion of fuel takes place, the burned gases expand and exert a large force on the piston, and due to this, the piston is pushed from top dead center to the bottom dead center. So the power impulse is transmitted down through the piston to the crankshaft, and the crankshaft to the connecting rod, and this causes the crankshaft to rotate at high speed. Thus, the work is obtained. So this power stroke is also known as the working stroke. So finally, the exhaust stroke. At the beginning of the stroke, the piston is at the bottom dead center, and during the stroke, the piston will move from bottom dead center to top dead center. During this stroke, the inlet valve is closed and the exhaust valve is open. As the piston moves upwards, it forces the remaining burnt gases out of the cylinder to the atmosphere through the exhaust valve. When the piston reaches the top dead center, the exhaust valve closes and the cycle is completed. So in the next cycle, the piston which is at top dead center moves to the bottom dead center by suction, and thereby allowing fresh charges to enter the cylinder, and the process continues. So which is the next cycle. So now the PV graph of diesel engine. So this is the PV graph for the diesel engine. So the suction stroke is represented by the line AB in this graph, this line, and the combustion of fuel that is injected takes place at constant pressure and is represented by the line CD in the PV graph, this line. The CD line is perpendicular to the pressure, so it is constant pressure. In the power stroke, the expansion of gases is adiabatic in nature and is shown by the curve ED in the PV graph, this line. This shows that the process is adiabatic. The drop in pressure at constant volume is shown by the line EB. The line EB is perpendicular to the volume, so which says that EB is constant volume. So the exhaust stroke is shown by the line BA in the PV diagram, this line. So this is exhaust stroke. So that's it for today's video. Thank you for watching and make sure to like my video. And if you have any doubts or any queries, comment your doubts in the comment section. Thank you for watching.